Okay, so here's B-5. So let's review the definition of continuity. So f of x is continuous at x equals a if three things happen. Number one, f of a is defined. Number two, the limit as x approaches a of f of x exists. That means the left hand and the right hand limit both exist and they are equal to each other. And then number three, and this is what we're going to be using today, the limit as x approaches a of f of x is equal to f of a. So what this says, guys, is that if a function is continuous, the limit is equal to the function value. Now, we've done a lot of work building up to this, and hopefully you've noticed that the limit is not always, the limit as x approaches a number is not always equal to the function value at that number. That's not always true. But if a function is continuous, that is the case. So what this third condition is telling us is that to evaluate a limit of a continuous function, we can do something called direct substitution. We can direct substitute. So here's the first example. F is a continuous function with the following table of values. Evaluate the given limit. So we know that f is continuous, and this table of values is telling us that f of negative 3 is 2. F of negative 1 equals 8. F of 0 is 5. F of 4 is 0, etc. So I look down here. I want to know the limit as x approaches negative 1 of this function here, 2 times f of x plus 3. Well, we know that f is continuous. And if you multiply a continuous function by a constant, you're still going to get a continuous function. And then if you take that continuous function and you add 3 to it, you're going to get another continuous function. So since f is continuous, this entire function inside here is also continuous. And we know from condition 3 of a continuous function that the limit is going to be the same as the function value. So this says that we can direct substitute. So if a function's continuous, you don't have to be thinking about numbers super close to negative 1 from the left and right. You can actually just plug in negative 1. So this is 2 f of negative 1 plus 3. Now, a thing that people usually struggle with here notation wise, excuse me, is that a lot of students don't drop the limit. Guys, notice, like in condition 3, there's the limit on the left side, but there's no limit on the right side. We have plugged in a. So same thing here. I don't have a limit here anymore. I'm dropping the limit. When you direct substitute, the limit is dropped. Okay. So this is equal to 2 times, what is f of negative 1? F of negative 1 is negative 8 plus 3. This is negative 16 plus 3. That's negative 13. Okay, now we're going to do two more little examples. So here's example number 2. Evaluate this limit. Now, guys, in the past, we could evaluate this. We could think of numbers super close to negative 2, and we'd be like 3 times about negative 2 squared minus 2 times. Okay, that's a lot of brain power. It gets easier the more you do, but that's more brain power than just plugging in negative 2. And this function here, guys, this is a quadratic. That's a continuous function. If you think of its graph, it's a continuous curve. There's no breaks. You don't have to lift your pencil up to draw it. So this is a continuous function here. So we could just plug negative 2 in for x, and that's going to give us the answer. So I'm not going to write limit here anymore because I'm direct substituting. And guys, here's a nice thing about direct substitution. You could always try it. So I did point out that this is continuous, therefore we can direct substitute. But if the function is not continuous at the x that you're approaching, then the direct substitution is not going to work. So it never is going to hurt you to try direct substitution. And that's actually always going to be the first thing we try when we're evaluating the limit. There's going to be a lot of different methods, but we're always going to try direct substituting first. And then if it doesn't work, we'll move on to another method. All right, so this is 3 times positive 4 plus 4 plus 1. This is 12 plus 5. That's 17. Okay, now here's an example where this function is not continuous everywhere. So the limit as x approaches 5 of this function. Now notice this function is not continuous at x equals -1 because that would make the denominator 0. Okay, so this function is not continuous at x equals -1. But over here in our limit, x is not approaching -1, it's approaching 5. So the direct substitution is going to work. So I go equals. I'm just plugging in 5. Notice I don't have a limit in front of it anymore. Okay, that's 28 over 11. All right, and that is the answer. All right, now when you're doing these exercises, guys, when you're doing these problems, make sure that you're using very careful notation. If you, for example, if you don't drop the limit, like when it's appropriate, that's not precise, careful notation. You're not using the language correctly. All right, so that's a problem. It's a problem we can fix, but it's nonetheless not correct. Alrighty, guys, I'll talk to you later.